Hey everyone, I'm Pratyush. I'm one of the co-founders of Eternis. And today I wanted to keep my talk a bit more philosophical. I don't know about you guys, but I've really been feeling the AGI with all the new models dropping and using them every day to program, build stuff, plan like weekly sprints for our dev team. And so I wanted to reconsider all the problems that we work on, which ones are the highest impact. And yeah, I think we have a great discussion going on in terms of various toolkits we have to solve the different types of problems. I'll talk towards the end more about why I believe that TEs are going to have an outsized impact on this whole landscape, and every single one of us will be using a TE, I believe, in the next year, and we'll see how. Yeah, so what are the most compelling privacy problems going forward? And I just picked 3 problems which I think are going to be huge regardless of how future models behave, even if models remain as good as they are. Yeah, so we'll start with human authentication and identification. It's an age-old problem. We've all dealt with this to some degree. This is why governments have national ID systems. They have passports, so you travel between countries, they can still identify you. You have bank accounts that require some type of identification. But there's also increasing sort of identification problems that are coming up in the modern world. I'm sure all of us claiming airdrops have seen people claiming 10x the airdrops as one person by using bots, like a lot of these different things. And in general, resources on the internet are increasingly being consumed by bots. Even no matter what your favorite chain is, if you actually look at how many transactions are bot initiated or initiated automatically, it's going to be an overwhelming number. Cool, so I'll just dive deep into these 3 problems quickly. So a simple problem of identification is this the same human across time? Let's say you have a system where you want to register unique humans because you want to distribute resources amongst them, or you want to plan some voting mechanism, things like that. You need a process where you registered unique individuals, and you need deduplication, which means that, let's say I go and register on day 1. If I go back on day 10, people should be able to find out, okay, this person is already in the system. One major effort towards this direction is WorldCoin, because ultimately it's only our biometrics that uniquely identify us, and biometrics are still really hard to copy off of people, and there's liveness checks and things like that to prevent spoof. Previously, people thought, okay, if I see someone on like a video call or if I hear their voice, I should be able to authenticate them with high probability. But now, like, all of the voice recognition and voice emulation models are really, really good. I recommend all of you guys try it out. With a 30 to 90 second sample of you speaking, it can basically copy you to high enough resolution that it'll be hard for people to distinguish on a phone call. So capturing people's biometrics in a privacy-preserving way and using that to deduplicate humans is going to be an important problem for resource coordination, be it compute resources, monetary resources, UBI, all of these challenges will find this problem, like the solution to it, very useful. The other sub-problem is if you're online and you're talking to someone, you want to find out they're a human or they're an agent or a bot. This is a really fundamental problem on the internet today because protocols down to the TLS level, transport layer security, which every time you connect to a secure website, you use this protocol. It was made for one-sided authentication. So what it was made for is for humans to check that, hey, I'm talking to Twitter.com. Is it actually Twitter.com? And I can cryptographically authenticate this information. But now there's an interesting problem that sort of flips it on its head, where it's like, websites want to find out if they're talking to a human or they're talking to a bot or an agent. There are a few reasons for this. Agents can click thousands of times in a second. They can consume a lot of server resources, so websites are resistant to letting agents go online. And CAPTCHAs are a band-aid solution to this, as I'm sure all of you have experienced. It's a cat and mouse game where the best models keep improving at CAPTCHA, and so the CAPTCHAs get harder. Eventually we'll reach a point where us humans won't be able to solve the CAPTCHAs anymore, and then this is not going to work. So we're going to need pretty a pretty big overhaul of the protocols here down to the TLS level. This requires massive coordination between the biggest technology players in the world, standardization organizations. So this is a major challenge that's coming up. And the final sub-problem on this part of my talk is rate limiting actions. So rate limiting is super important. Again, in the context of voting, you want to make sure that one person can only vote once. If you're taking on-chain actions, you decide that there's a smart contract where you want one human to have one voice or one vote or get one portion of the resources. You need to rate limit their actions without compromising on privacy. So what this means is I sort of find out when someone is taking the action, if they've taken this action before, or I let them take the action. And this is kind of easier in the world where everyone has a public key and everyone has a secret key. So there's this thing called nullifiers that has been used on the internet since the Zcash days, where people can spend money without sort of revealing like what notes they've spent or not. It kind of becomes challenging when you don't have a high entropy PKI. So if you are just using people's like Twitter accounts or their GitHub accounts, first of all of these accounts are public. Sometimes there are even user IDs that are like a 10-digit user ID for each individual. So it is possible with even your laptop to iterate through all of these IDs and find out if someone has voted or not, if it's a public protocol. So you end up needing a situation where you want to coordinate an action within public identifiers that are not public keys, so something like Twitter usernames, and you want to create a system where you vote and one account gets only one vote. The only way to do this is to add some secret information by a trusted orchestrator that says like, hey, like I have this user ID and there's this secret salt, and that's the bit that decides if someone has voted or not. If this is already stored, then this person has voted, otherwise not. Again, creating a privacy issue because there's one party that knows everything, others don't. Cool. So that was the first part in terms of the challenges there. I think in terms of solving these problems, we require a bunch of things. For example, for biometrics, you need trusted hardware. It's not necessarily a trusted execution environment, but it's just a trusted biometric device, which is tamper resistant. You want to make sure that some operator cannot just break it apart and game the system and register thousands of people when those people are not at the registration site. I think the second big problem is pooling intelligence. And by pooling intelligence, I also mean pooling data. There are interesting movements going on right now, especially a lot of you who might follow Brian Johnson might see this, right? There's a group of biohackers that want to capture a lot of data on their day-to-day activities. There are smaller groups of biohackers that are also trying to compute on this data together, of course, without compromising their privacy. There are multiple large-scale examples. I just picked this one between Intel and Penn Medicine. So based on millions of medical images amongst like patients that have a shared demographic and a similar goal, you use this data to train models to find better diagnostic solutions, be better informed around the health choices you make. In general, pooling data that is authentic, so authentic data about my health, your health, if we collaboratively compute on this will result in faster diagnostic outcomes for most things because data is the issue there. Yeah, and then you can use the same framework and apply it to different places. The piece of technology they used in this experiment is called federated learning. Most federated learning algorithms that have high accuracy require a trusted orchestrator because there's a problem where there's multiple people that have data, one person or one party can poison the data and then your model sort of becomes useless. So you need a trusted orchestrator and you also need some authentic data. So you know that the model is not being poisoned. Yeah, and then there's also the question of attribution. Say all of us pool our data to train a model. The question of who owns this model. So this is something that us in crypto, people think about this a lot, right? You do something together, shared incentives, shared attribution. Seems like us as an industry, we've thought about this problem a lot, so it seems like a good problem solver fit for this industry. And doing this without a trusted orchestrator, obviously, maybe use some trusted hardware, or you require the orchestrator to compute everything in a ZKVM environment, so you know for sure that they're taking all the actions they're supposed to do correctly. But again, the challenge there is if you're training a massive model, a ZK proof of training, even today, is prohibitively expensive to do for any meaningful model. Cool. And yeah, the third biggest problem, I think, that is a privacy challenge and an important pets application is personal agents. So what will personal agents do? This is a question that I've been thinking about for a few months with my co-founders. And here's my hypothesis on what they're going to do. I think personal agents at large will do three main things. So first, they'll improve your lived experience. We've seen some product market fit with different sort of AI companion projects that help people, deal with challenges in their life better, have some companionship. The second biggest one is enhancing your leverage. So all of us have certain skill sets that we're great at, and we get monetary rewards based on it. And yeah, these skill sets are limited by the fact that I can be only here giving a talk once, whereas I could give this talk 10 times in parallel if my personal agent was there with me today. So yeah, personal agents can help replicate your highest value skill sets at scale. Hopefully you will own them. Otherwise, it's going to be really challenging to generate any monetary value in the future. And the third one is immortalizing your presence. Maybe all of us as founders are like, I wish Steve Jobs was here to give me some advice on how I should deal with this challenge. But maybe now we can have a mentor be with us forever whenever you have a question in your head. Right? Currently, there's only one sort of player in the space that is building on personal agents and has enough distribution that there's a serious chance that they might be the only providers of this in the near future. Over time, people will catch on. But one of my goals with this talk is to tell people that this is actually not as challenging to build. The hardest part is the distribution. So what Apple is doing right now is they're saying, look, we're going to have on-device intelligence. So what we're going to do is we'll have an ensemble of on-device models. All of your data lives on your own device. For the most part, the inference and the data never leaves the device. So it's all good. The model computes whatever things I need, next word prediction, maybe the best filter for my images. It doesn't have to go to a server online. But at some point, I will be asking for things where you need a really powerful model, right? So maybe a GPT-01 preview type model that can think and solve through a serious problem that I have. So at that point, what they are proposing is there's a private cloud compute model. Your data is encrypted and is sent to this model. It computes whatever output it needs to, sends you back the information, deletes your data, everything is good, right? That's what they're saying. At a high level, they prevent any user-specific targeting, so the information that is sent to the servers doesn't have any identifying information. They promise that there's no backdoor, so even Apple employees cannot find out information that you send to these servers. And they are sort of following the trajectory of other TE companies that say, okay, there's verifiable transparency. So what that means is there is some software that turns into a software image that runs on trusted hardware, and researchers would be able to study these software images to make sure that Apple is not doing something fishy. This is still up in the air because it's not really clear how they're going to achieve this without making the software itself open source and without making all the hardware design open source. So this is more of an optics thing. It's better than most things that have been done by big tech in the past, but this is the state of the art. They will securely boot this hardware space. Your data would be deleted securely using cryptographic protocols. And one major thing they promise is resistance to sophisticated physical attacks. So the biggest disadvantage for TEs that has been talked about a lot in the space is co-location attacks. So all the TE attacks that you might have heard of, most of them require co-location with the actual hardware. So In the last decade or so, Intel started shipping TEs inside most computer and chips that they were making. And people started noticing by using really sophisticated techniques, you can read memory, or you can read execution patterns on the hardware itself. One very interesting thing is none of these attacks actually work if your hardware is hosted in the cloud. Unless someone can get access to the cloud physical hardware, they won't be able to execute this attack. I'm personally okay with this assumption because this is an assumption we've had in cloud computing for the last 2 decades, that the physical location is protected. But it's nice that Apple is pushing through the barriers and saying that even sophisticated physical attacks are not possible. So yeah, I think this is a risky situation though, because Apple has the most data on the users. They say this data like stays on your device. Perhaps you even own it. It never goes elsewhere. But there's a lock-in, right? If you ever switch your Apple device for another one, you lose a bunch of data. Now suddenly you have your personal agent that's making you $1 million a year. And Apple is like, hey, you have to pay me $100K every year for this. Otherwise, you're going to lose access. Your loved ones are not going to have an ever-present model of you, and then what happens then? If there's no choices, then we're kind of stuck here. There's also another problem, which is that the more you interact with personal agents and models like that, the better they become. It's training grounds. And then, yeah, the future generation like uses these interactions to train and become better. These models should ideally be open source because they are trained on like our data and our interactions, and you should be able to take your personal agent and go to any hardware provider. So what can crypto builders do? I think we're in a really interesting timeline right now because if you think about zero knowledge proofs, MPC, FHE, a lot of the largest deployments for these things outside of big tech have been done in crypto. And we've been sort of leading the charge in terms of bringing this new technology to market. And we are in an interesting timeline where we need to push back and we can build some of this technology fully open source and auditable. As much as we can. Of course, there's interesting challenges with building hardware, like trusted execution environments. You need to make sure that you have a hardware manufacturing fab and things like that. But with a coordinated effort, we can actually push for a future that's more open source and we own our personal agents and solve the other trust infrastructure challenges that are going to be coming up in the next 2 and 3 years. So these are some of the things that we've been thinking of solving at Eternis. Yeah, that's it for my talk. Thank you.